Hi, I'm Benjamin Squire. I work for Meredith Corporation as a senior data scientist on our identity team. So, when you visit a website, typically they drop a cookie that is used for informing us about what web pages you visit on our website, and that way we can kind of glean insights into what your interests are. And previously, that cookie was the only thing that we had to understand a person's behavior, but the lifetime of a cookie often is very short due to people deleting their cookies, or firewalls, or the browser using preventing cookies from dropping, etc. And so what we've done with this identity graph is we've actually been able to use multiple streams of data that previously we'd have one stream of data that would say this person's behavior looks like this, and we'd have another stream that it's somewhat matched up, but it wasn't able to easily join based on the connecting factors, I guess. And so by using the graph, what we've done is we've tied together those data streams by looking at commonalities between the two streams. And you can think of it like a join in SQL, which is basically like identifying a key that is similar in both tables. And so because of the graph's nature of connectivity, we're actually able to kind of look at all of the different things that connect these data streams together, and then that allows us to recognize the same user over time better than we could do before by just looking at a cookie itself. And so the short story of it is that we basically have increased our understanding of a customer by some 20 or 30% by just looking at how the data connects over time rather than just looking at individual cookies themselves. Well, with the traditional database approach, basically we had to treat them as separate streams of data, and we had no way to really link them together due to conflicts of timestamps and some cookies not matching up, and the number of joins to bring those data sets together would have been too much computation to actually combine all of those data streams together. And so we ended up using a graph database that allowed us to, instead of worrying about the timestamp and where the data was coming from, we could actually link them together and create a confluence for all those data sets. So Neo4j stood out for the ease of actually bringing in the data in the beginning, and then once we were exploring it with the pattern matching of Cypher, we were able to identify the data that we were looking for, which is basically understanding how cookies connect over time, and how we could use that to create profiles of people visiting our websites rather than focusing on individual streams and cookies by themselves. We actually were creating groups of cookies or profiles that represented what our customers were reading about and interested in a lot better than we had the ability to before using just traditional databases. And actually the Graph Data Science suite enabled us to identify and enumerate these patterns. And so not only were we able to identify the data we were interested in, but then we were able to actually bring that and export and act upon that data as well. I guess it was, what was the most surprising was really seeing how connected the data was. I used to think that we knew this data really well when we looked at it individually from each different data stream. But when you combine them all together and you actually look at the data sets as a whole, it makes you realize that it's like trying to solve a Rubik's Cube puzzle by only looking at one side of it. With Neo4j, we're actually able to combine all of these different data sets, and it's like seeing the Rubik's Cube in 3 dimensions, and it made it a lot more easy to comprehend and understand how to act upon it. Graph algorithms enabled us to really scale what we were after. When we started out with just looking at the patterns of data that we were interested in, it worked, but it wasn't efficient in that we had to basically do the same computation millions and millions of times, which wasn't scalable to the billions of cookies that we had. And so the power of the algorithms is that we are able to actually apply this computation of weakly connected components, or union find, across the entire data set, which, it was challenging due to the data size and fitting everything into memory and making sure the hardware matched what we needed it to do. But it was able to avoid having to repeat the same small cipher computations millions of times and just do it globally at once using the in-memory Neo4j algorithms. I would say the best part really is the community. When I was developing this project, we had a lot of challenges with getting the data in and trying to scale to the level that we have now. And it was really through the community.neo4j.com website that I got a lot of answers, and that was really helpful. It was both answers from staff and other Neo4j enthusiasts like myself. And so I would say probably the community is the best part about working with Neo4j. Yeah, so where we're at with our project now is we're still pushing it into the commercial space and delivering it for our advertisers. But besides that, I really want to push the analytics of Neo4j and look at some of the other algorithms that are available. Right now, we're really focused on just making the data more efficient and getting the runtime down for processing this much data. But what we'd like to do is really gain more insights by using some of the other algorithm suites that are available. Yeah, with Neo4j, I think that you have to focus in on what you're after. Like at first, when we started out this project, we kind of threw all the data we could in there. And as we scaled it, we realized that we really need to pick and choose our battles. And I think that's one of the challenges with graphs is that because it's such a new way to look at your data, just like I said with the Rubik's Cube analogy, when you look at it from that third dimension, when you start seeing all the different sides of it, you start to think, oh, well, I can solve all of these problems at once. But when you start scaling to 20 billion nodes, basically focus in on exactly what you're trying to solve. And have a different graph for each type of project to really focus in and scale to the size that you're after. So, and use the Neo4j community a lot. Ask questions, people are responsive, they can help you out a lot.